So for what range of k does root 7x squared plus kx plus root 7 equal to 0 have real roots? So we should know that for a quadratic equation, ax squared plus bx plus c equal to 0. For it to have real roots, it must be b squared minus 4ac must be greater than or equal to 0. That's for it to have a real root. So from here we see that k is b, so k squared minus 4 times root 7 times root 7 is greater than or equal to 0, and this is k squared minus, this is 28, so this is 28. So from here, we can write this as difference of 2 squared, yes. So I can write this as root 28 all squared. And this is now k minus root 28 times k plus root 28 is greater than or equal to 0. Okay, remember, to solve a quadratic inequality, we'll solve as if we are solving quadratic equations. So let's solve that k minus root 28 times k plus root 28 equal to 0. So why do you do so? We know a quadratic equation will have two answers when it is equal to 0. But for it to be less than or greater than 0, meaning we have other numbers, we have millions of numbers that will satisfy that, but we have only two that will satisfy equal to 0. So what do? We'll solve as if we are solving to get equal to 0. We get the 2 and we now use it to form interval. We'll test. So that's why we do 2. It's easier to get the 2 that will give us 0 than to get the millions that will give us greater than 0. So we'll solve this. So if we solve this, this is now k equal to plus or minus root 28. Yes, if this crosses plus, if it crosses minus. So these are the two answers that will give us 0. So we now form interval. We'll test. The smallest one is minus root 28, while the big one is root 28. So let's test numbers. Instead of wasting time testing numbers less than minus 28, let's test numbers between minus 28 and plus minus root 28 and plus root 28. So 0, if we test 0, if we put 0 here, we now have negative answer times positive, which is negative, but what they gave us is positives. So all the numbers between minus root 28 and that will fail. That will satisfy our numbers less than minus root 8 and numbers greater than plus root 8, yes. So whenever you are solving quadratic inequality, if you test this middle and it fails, the answer will be this and this. Or if you test this and it's satisfied, this will also satisfy numbers greater than the greater one and numbers less than the least one. And so that's it. Or we can still test to show you that we're correct. Okay, let's test numbers less than minus 28. Let's test minus root 50. Minus root 50, this will give us negative. Minus root 50, this will also give us negative. Negative times negative, positive. Do you see it? So that's why I say once you test here, let's test numbers greater than root 28. Let's test root 50. Root 50 here positive. Root 50 here positive. Now if we put root 50, this will give us positive. This will also give us positive times 2. So that's why. So our answer will be numbers less than root 28. But remember, there is a equality sign, so equal to 0 is included, or numbers greater than or equal this minus greater than root 28. So the answer, root 28 means 2 root 7. Yes, because 4 times 7, square root of 4 is 2. So which is the answer is equal to, so the answer is option C. Yes, that's it. The answer is option C. So whenever you are solving quadratic inequality, solve as if you are solving quadratic equation to get the two numbers that we use in forming the intervals. We now use it to create interval, 3 interval. We now test, and if you test anyone that fails, you can get the answer. If the middle, the number that is between the two number fails, means the ones less than the smaller one and the ones greater than the larger one is the answer. That's all will come in. But if this one fails, the extreme ones, meaning this one will, so once one fails, if this fails, this also fails. So you don't need to waste unnecessary time. So test the middle. If it fails, means that the answer is the other two, or joining with or. So that is it. Thank you.